I'm sorry, 6.3 is on elastic and inelastic collisions. One we did last time, the problem where we found the baseball and the bat colliding to use that equation. That was for an elastic collision. Okay. Um, so there's two different types of collisions, or two different ideal types. In reality, all types of collisions are a combination of both. But we'll look at one. Usually, collisions approach one type or approach the other type, and we'll look at both types um, of those. So they do. There's two things that can happen when things collide. They can either bounce off each other, or they may stick together. So elastic collisions bounce off each other and they also conserve kinetic energy. But we'll bring in more of that later when we get to impulse momentum and conservation of energy. In inelastic equations, collisions, they stick together and energy changes form in the deformation process of them sticking together. So kinetic energy is not conserved in these. However, momentum is conserved for both. So we will conserve momentum for both in these conservation of momentum problems. So we saw already what the elastic equation was, and let me rewrite that. It was m1 times v1 plus m2, so this is for elastic, v2, or onward, like you could have momentums of more than two objects. You could have three, so you could continue the number pattern, m3, v3, etc. Or m1 v1 prime plus m2 v2 prime. It equals that, which means the mass times velocity of each thing afterwards. And I wrote this as speed, but we could use with plus minus if it's in one direction, but if it's in at angles to each other, we'll use the vector quantities and vector mathematics for those. And we'll do problems like that, so you'll get experience with them. Now for the inelastic, because they stick together, it's actually a little bit easier. So we have the separate mass and velocity before the collision. And then when they stick together, we have an m total, which is m1 plus m2 times just one velocity afterwards, v prime. So let's look at an example, again, with first the elastic. Okay, a 45 kilogram box sitting in the road is hit by a 1,200 kilogram truck traveling at 30 meters per second. The box bounces off the truck, elastic. During the collision, the truck slows to 29 meters per second. What is the box's final speed? So we have this truck traveling along. We'll call this way positive. The initial speed of the truck is 30 meters per second. We'll call that V1. The box is just sitting there. So the box, its initial V2, or V2 for the box, but initially, before the collision, is 0. These two things collide. Oops. In a collision, and then afterwards, the truck slows to V1 prime of only 29 meters per second. Ugh. Okay, so the question is, what is the velocity of this box afterwards? Okay, so we'll use our equation for elastic up here. Whoops. What the freak? Gosh. Didn't want this to take so long, but whatever. Okay. There's our equation. So the mass 1 of the truck is 1,200 kilograms times its initial velocity of plus 30. Since the initial velocity of the box is 0, this is going to go to 0. So, because it's not moving. And then afterwards, the truck slows to 29 meters per second. And we want to find the velocity of the box, which happens to be 45 kilograms. It's V2 prime. So 1,200 times 30 gives 36,000 kilograms times meters per second. And 1,200 times 29 is 34,800 kilograms times meters per second, plus 45 kilograms V2 prime. So 36,000 minus 34,800 gives 1,200 kilograms times meters per second equals 45 kilograms times V2 prime. Divide that by 45, and we get that V2 prime is a positive 26.7 meters per second. So the box would shoot off at that speed. Of course, since it's slower than the truck is still going, it would shortly after hit it again. But we were just looking at the one part. Let's look at another problem. In this problem, we have a box, again, 45 kilograms, sitting in the road when it's hit by a 1,200 kilogram truck, traveling at 30 meters per second. The box gets stuck in the grill of the truck. What is the final speed of the truck in the box? And for this one, we'll make use of the inelastic equation. Oops. one right here. Because they stick together. So we have the truck traveling along, and its initial speed is again 30. We'll make this way positive. The box is sitting there. Its initial speed is 0. They collide. They stick together. And they move off with a velocity that we don't know we're going to look for. We know the mass of the truck. We can plug in M1. Oops. 1,200 kilograms. We know it's moving at 30 meters per second. The box isn't moving before, so this is 0 prior. Equals the combined mass of the two afterwards. 1,245 kilograms. And we're going to look for the speed of that combined wreckage. 1,200 times 30 is 3,600. Oops, 36,000. Divide that by 1245, and we get the speed of the wreckage is 28.9 meters per second off like that.